Hello and welcome to a lecture based on relations and functions. Today we are going to deal up with the subtopic of relations and functions, which is binary operations. Today in this lecture we are going to deal up with the binary operations. Later we are going to discuss the properties of binary operations, and finally we shall conclude this lecture based on binary operations by discussing a numerical problem that would be based on the properties of the binary operations that we are going to discuss in the coming segment of this lecture. So beginning with the basic definition or meaning of a binary operation phi on a set A is a function from A into A to A, that is, can be represented as phi is to A into A tends to A. Now phi, which is a function of xy, can also be denoted as x phi y. Now here we use a symbol for phi as plus indicating addition, dot representing multiplication, minus representing subtraction, and star representing any mathematical operation. Next we are going to consider a binary operation that is well defined. A binary operation is well defined if and only if whenever x is equal to q and y is equal to t, then the binary operation on x and y is equal to the binary operation on q and t. Next we move to the properties of binary operations. The first property is the commutativity. A binary operator denoted by star is said to be commutative if and only if the binary operation on A and B is equal to the binary operation of B and A for every A and B in S. Now here real number addition and multiplication are commutative operation, while subtraction and division in the real number system are not commutative. Another property of binary operations is associativity. A binary operation denoted by star is said to be associative on the set S if and only if the binary operation on x and y along with the binary operation of z is equal to the binary operation of x and the binary operation of y and z, which can be represented as bracket x star y bracket close star z is equal to x star bracket y star z bracket closed for every x, y and z in S. Here both addition and multiplication in the real number system are usually defined as associative operations. Another property associated with binary operation is closure property. A binary operation denoted by star is said to be closed on a set A if and only if whenever x belongs to A and y belongs to A, then the binary operation on x and y is also an element of A. Next we are going to study the possession of an identity for a binary operation. A binary operation denoted by star defined on a set S is said to possess an identity if and only if the binary operation on x and E is equal to x and the binary operation on E and x is equal to x for every x in S, where E denotes the identity element. For example, 0 is the identity element for addition in real number system, since 0 plus x is equal to x plus 0, which is equal to x for every real number x. Whereas for subtraction, 0 is not an identity element, since x minus 0 is not equal to 0 minus x. Next we are going to discuss the inverses of binary operation. Now here we cannot even use the term inverse unless the set S is known to possess an identity E with respect to binary operation star. If this is the case, then x in S is said to possess an inverse under the condition that the binary operation on x and its inverse is equal to identity and the binary operation of x inverse and x is equal to E, where x denotes the element whose inverse is x inverse and E is the identity element as we have discussed earlier. Finally, we are going to discuss a numerical problem based on the binary operation of the given function. Now here we have a problem that states that let star be the binary operation defined on the set of natural numbers which is given as n equal to 0, 1, 2, 3 up to infinity, and the binary operation is given as a star b which is equivalent to a to power b. And here we are required to find is the binary operation, that is a to power b, is commutative or not, and also is it associative or not. Now, as discussed in the previous segments of this lecture, for commutative the function should be of the form a star b should be equal to b star a, where star represent the binary operation which is defined on the given set of numbers. And thus to find whether the given function is commutative or not, suppose a to be 2 and b to be 3. Now operating this function by the use of this binary operation, we have the value of this operation as 2 to power 3, since the binary operation is defined as a to power b. This is equivalent to 8. Thus operating 2 and 3 by the use of this binary operation, we have the value as 8. Next we are going to find the value of 3 star b, which represent b star a. This is equal to 3 to power 2 as specified in the given question. This is equal to 9. Now as is very much evident that the value of 2 star 3 is not equal to 3 star 2, thus the given binary operator is not commutative. Next we are going to find out that whether the given binary operation is associative or not. Now as discussed in the previous segment of this lecture, for a binary operator to be associative, we have bracket x star y bracket close star z is equal to x star bracket y star z bracket closed, where x, y and z can be any natural number as specified in the given problem. Now here for example, let us consider x equal to 2, y equal to 3 and z equal to 4. Then the value of this function is equivalent to 2 to power 3 star 4, where star represents the binary operator. This is in turn equal to 2 to power 3 with power of 4. This is equivalent to 2 to power 12. Next we are going to find the value of 2 star bracket 3 star 4 bracket closed. This is equivalent to 2 star 3 to power 4, where 3 star 4 is replaced by 3 to power 4 by the use of the given binary operator. This is equal to 2 star 81. Now we can replace this and rewrite it as 2 to power 81. Now here we note that equation 1 is not equal to equation number 2, which was required for the operator to be associative. Thus we can say that star, which is the binary operator, is not associative. Thus we have found that the given binary operator is neither commutative nor associative. With this we conclude the lecture based on relations and functions, in which we dealt with the binary operations and their properties.